Hi to everyone. I am K. Satish Kumar, working as an assistant professor in the Department of Automobile Engineering at Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to see what is mechanism, their types, inversions, and the applications of mechanism in machines. First of all, what is mechanism? A mechanism is a set of procedure how the links are arranged and how the movement of one link can be converted into some other movement of another link. In this figure, you are seeing a simple mechanism. A mechanism mainly classified into three main types. They are 1. 4-bar mechanism, 2. Single slider crank mechanism, 3. Double slider crank mechanism. The 4-bar mechanism have 4 bar. They are 1. Frame, 2. Input link, 3. Transmitting link, 4. Output link. In the figure, common name is given to 4-bar mechanism as AB is act as frame, AD is input link, BC is output link, CD is coupler link. In actual machines, the name may be changed like AB is cylinder. The cylinder is a main reference link which supports all the links to work in a good manner. AD is rotates in this diagram which gives input to the entire 4-bar mechanism. Link CD acts as connecting rod which transmits the rotational moment of AD into the output link BC. The BC is act as output link which oscillates the arc placed in the diagram. So at the end of this 4-bar mechanism diagram, we can see that the continuous rotation of AD can give an oscillatory motion of link BC. So here you can conclude that the mechanism is used to convert the movement of one link to another movement of in some other link. By changing the link from a reference link to input link and input link to transmitting link, we can change or get some kind of rotational or some other movement. By changing this link is called as inversions of mechanism. So here after we are going to see inversions of 4-bar mechanism. First one is beam engine. The beam engine is also called as crank and lever mechanism. Here one link is rotating and another one link is translating. In this diagram, link 1 is fixed and act as frame. Link 2 act as crank, rotates fully. Link 3 translates the rotational moment of link 2 to link 4. The link 4 further translates to the cylinder. So by the arrangement of the link, we can convert the rotational moment of crank to the translatory moment of output link. So because of this mechanism, we can use wherever we need a translatory movement. Second one is coupling rod of locomotive or double crank mechanism. In this mechanism, one link rotational movement is transferred into again the same rotational movement in some other places or some other link. In this mechanism is used in a railway, that is why it is called as coupling rod of locomotive. Here also link 1 is act as frame. Link AD is rotating. Link 3 translates the rotational moment of link AD to link 2 and link BC gets same rotational moment and rotates some other wheel. By the continuous arrangement of this mechanism, we can move a lengthy part of goods to in a smoother manner. So number 3 is Watt's indicator mechanism. This mechanism is used to draw a straight line. Because of that, it is also called as Watt's straight line mechanism. In this diagram, it can be shown as link 1 is fixed, link 4 is used to transmit the movement from the indicator plunger to the mechanism, link 2 oscillates and changes the output link to move in a straight line, link 3 acts as output link. So from the diagram we can say that initially the link or the mechanism is in the zone of BFDC. After giving input to the entire mechanism, the above set links are moved to B dash, F dash, D dash, C dash. It gives some oscillation, but at the end the final output is E to E dash, which makes a straight line. Because of that, I have already told the mechanism is also called as Watt's indicator mechanism. These three mechanism is in the category of 4-bar mechanism. In the 4-bar mechanism, initially first one is act as crank, 2 transmitting link, 3 output member, 4th is act as frame. If one rotary link is converted to sliding member, then the mechanism is called a single slider crank mechanism. In this category, one member is continuously used to slide in the required zone. So this is the common diagram of single slider crank mechanism, where the piston slides inside the cylinder and the connecting rod transmits the movement of piston to the crank, where the crank rotates and link 1 is acts as frame or cylinder. We can also reverse this operation. By rotating the crank, we can move the piston in a straight line or slide inside the cylinder. This is single slider crank mechanism. The first invention of single slider crank mechanism is pendulum pipe. Pendulum pump is used to in a water pump we are using in our household, where the crank 2 is rotating and the cylinder which are attaching in both the end is sliding inside the cylinder. By this arrangement, we can get the translatory movement as output. Number 2, oscillating cylinder pump. Here link 3 is fixed, that is connecting rod is fixed, link 2 is given rotational input, link 1 is transmitting the movement of crank 2 to the cylinder and link 4 is cylinder. So by this mechanism, the rotational movement of crank or link 2 oscillates the entire cylinder, not the piston. The entire cylinder is oscillates. And third one is rotary engine. In this type of engine is used in air flights, where multi cylinders are connected in a circular manner. A single crankshaft is rotating entire piston in a straight way manner. Number 4, crank and slaughter quick return mechanism. In the machines, especially the shaper machine, the tool is used to cut the job in one stroke, that is in a forward stroke. At the end of the reverse stroke, the material is not cut. So scientists developed this mechanism where the tool is moved in a slower manner while forward motion. While returning, the tool returns faster than the previous forward stroke because it is not going to touch anything. So this mechanism, single slider crank mechanism, gets an inversion, gives crank and slaughter quick return mechanism. Here a link 4 is act as slotted bar and link 3 is fixed, link 2 is given as rotational input and link 1 is slider mechanism. First, initially the slaughter is in P1 position. At forward stroke, the slaughter moves in an arc manner from P1 to P2. while the link tool is cutting the job. But at the end, while the returning, the slaughter moves from P2 to P1 in a straight way manner. So the which gives a smaller distance to cover up. Because of this, the tool moves in a fast manner. This mechanism is called as crank and slaughter quick return mechanism, where it is applicable in shaper machine. Here we are going some data's time of cutting stroke divided by time of return stroke. At the end of finally we can see that the cutting stroke has maximum distance than the return stroke. The Whitworth quick return mechanism is also like previous, where the cutting stroke is maximum than the return stroke, but some complicatory movement or the arrangement of links is isolated this mechanism of usage. It is also used in some smaller portions where the mechanism is maybe in some complicated position. So this mechanism is used in shaping and slotting machines. In this mechanism, the four links are used as in previous manner. One link is fixed and another one link is act as slotting member, and link 3 is given as crank, and link 4 is an output member. By the rotation of crank 2, we can transmit the movement of rotational movement to the final output member of the transmitting link. Then we can say we are going to see double slider crank mechanism. If in the 4-bar mechanism, two members or links are used to slide, then the mechanism is called as double slider mechanism. By using this concept, if we convert any members from their position, we can get some number of inversions. In the first one is elliptical trammels. In elliptical trammels means it is used to draw a ellipse. Here we can see link A and B are sliding in a fixed path, where link 2 connects A and B. Link 4 is act as a slotting block. So by the movement of link A, B in a sliding motion in a fixed path, we can get an ellipse in a described manner. So here are the derivation. We can obtain an elliptical formula x squared plus y squared is equal to ab squared, which is the elliptical formula we can arrive at last. Second one is Scotch yoke mechanism. Scotch yoke mechanism is used to convert the rotational movement of crank in a sliding movement inside the cylinder of another link. Here the link 4 is fixed, link 1 is used as a rotational input, link 2 is transmits the movement from the rotational member to link 3. And the last one is Oldham coupling. The Oldham's coupling is used to connect two unvariant cylinders. Here you can see that cylinder C, or plate C has a hole in the center, where cylinder D is has hole in some other position. But if we have a situation to convert the movement of cylinder C and D in a straight line or in a single pipe, what we needed to use is Oldham's coupling. The Oldham's coupling has two holes similar to the plates C and D. Because of this Oldham's coupling plate, intermediate plate, exactly matches with the link C and D, so that the entire rotation of C is converted into the rotational again to the output member D, so which is further we are using very smoother manner of transmission. So in this video we have seen mechanism and the types and examples of mechanism usage in industries. Okay, thank you.